All right, I'm going to go ahead and introduce both of them. Andy's going to speak first, and then Erica, as he said, is going to do cleanup. Andy Hirsch and Erica Carlson are both physics professors here at Purdue who have made a great use of technology in the classroom to create active, student-centered learning environments. They're here to share with us the technology they used, how they implemented it in the classroom, and how they felt that it contributed to student outcomes. And Andy's going to begin.
So first I want to say that the previous two speakers really laid the groundwork for what I'm going to talk about, which is essentially a flipped classroom for first-year engineering students who have to pass through the physics gate in order to proceed with their engineering careers. This is a very challenging course for first-year students, primarily because of the way physics is taught in high school. If you ask a first-year engineering student, and perhaps even a physics major, what they think physics is about, they will tell you that it's about finding an equation to solve a problem. And so a major task is to disabuse the students of that notion and instead to build a foundation that allows them to solve a wide variety of problems from a few fundamental principles. So a moment of truth in advertising, I'm not a heavy user of technology in the classroom. So let me describe what I do, and there are some elements of technology. So first, we have been teaching this particular course in this form, using this textbook, Matter and Interactions, for about 18 years. And when the Active Learning Center at Purdue was opened up, I made sure that I was on day one in there using what I call the scale-up space. So the traditional format has about 2,000 students per semester, per year rather. Keep going, yeah. So Scale Up stands for Student-Centered Active Learning with Upside-Down Pedagogies. That acronym came from Bob Buechner from North Carolina State University, who developed the particular format of the flipped classroom. Yeah, okay, so I had, in essence, a very nice laboratory starting in the fall of 2017 and continuing now. So the traditional format class has two 50-minute lectures, one 50-minute recitation period, and a 2-hour lab. So what I did in my redesign was to take the three 50-minute periods and divide those in two. So I have two flipped classroom meetings per week, 75 minutes each, and then the 2-hour lab. I have different online homework, and I'll say a little bit more about that. And basically, what we do in the classroom is we solve the problems that the regular students do online. Now, why did I do that? Because I know very well that the online homework done by the regular format class, those are end-of-chapter problems, and they're good, but students know how to solve those because they can find solutions. And in fact, I did the following test. I took a problem that 81% of the students who did it online got correct, put it on the exam, 30% got the same problem correct. So to me, I've always been skeptical about the effectiveness of online homework, and this more or less proved my point. So the advantage of flipping the classroom and working the better end-of-chapter problems is, as our previous speakers noted, you can intervene at critical moments in the thinking as you circulate around the classroom. So let's go to the next. So what we do is myself, my graduate TAs, and my undergraduate teaching assistants, we are in constant motion throughout the 75-minute period. So we have 12 tables, 9 students to each table working in 3 groups of 3 on whiteboards. So we pose the problem. We have, yeah, that's good. So this is myself intervening during a problem-solving session where a student is pointing to something on the whiteboard and asking the student to justify. So the most to myself and my TAs, what is so critical about the flipped classroom is the ability to intervene in real time. And so I know that we're, from now years of experience, exactly where the tricky parts or the difficult parts are in each problem. And this is an opportunity then for us to have a discussion with students, ask them to justify their reasoning, or in some cases to correct mistakes they've made, conceptual mistakes. Yeah. Okay, so the bit of technology that I did use was the following. I took the traditional PowerPoint slides and I spent a summer converting those to what I call bite-size videos. So I took a 50-minute PowerPoint lecture that's delivered in the large lecture hall, and I created anywhere from 5 to 8 minutes chunks. So one 50-minute lecture may be one 8-minute video, or it may be 3 5 to 8 minute videos. And then after examining the viewing habits of my students a year or so ago, I realized that as a function of time through the semester, their viewing habits fell off. In other words, they were not as, they didn't view the videos as frequently as I had desired. So I made use of a technology called, is it on here? Called PlayPosit, which allowed me to take an already produced video and drop a question at the end. And this was so what I did is at the end of each video, after my summary slide, I have a multiple choice question. And the question is non-trivial. So it really probes the understanding of what was presented. And I offer 1 point for a correct answer. So there's a little incentive, as Bob Buechner used to call these biscuit points. It turns out that engineering students will do anything for a biscuit point. So they will take that quiz. And it's meant to make a point. And the other thing that I did, and this is again outside the classroom, I created a new set of homework problems using a different online homework platform, Expert TA. And that platform scours the web for posted solutions to their problems. And then if a student posts a solution to an Expert TA problem on, say, Chegg will get a call from Expert TA lawyers to pull that problem. So it's not so easy to, students actually have to do the online homework. And I've designed those online homework problems to reinforce some of the main points we make in the classroom. The other thing that I do at the beginning of every class is I have the students take an online, relatively short, 3-question, multiple choice quiz embedded within Blackboard, our current learning management system. And I allow them to discuss this with their neighbors. This is a low-stakes quiz, but it touches on the material that they should have read in order to be prepared to work on the day's problems. The other use of technology that I have made use of is Hot Seat outside of the classroom. So Hot Seat is is everybody familiar with Hot Seat? No. So Hot Seat is a web-based application where I can pose a question, Students can reply. Other students can vote. Yes, I agree with that response. You can use it live in the classroom. I chose not to do that because I've got enough going on in the classroom. Instead, I pose a question each week, and then I allow students to respond to that question on their own time. And I will admit that that is underutilized at the moment. Okay, so, and Gradescope is another technology that I use outside the classroom. So our recitation takes place, our recitation problem is embedded within the scale-up format. Every Thursday, we hand out a hard copy of a recitation problem. And this problem is, I should have said this, everything we do in my scale-up class, the regular students do. They may do it in a different format. So the same recitation problem that the regular students see, my students see on Thursday. And what I ask them to do is collaborate, and then each team of 3, they all sign each other's papers, and then after the class, I will assign one individual from each team to upload that paper to Gradescope. And Gradescope is a wonderful system that allows you to grade each paper in a PDF form using a rubric that I have developed. And it's very efficient. So, and another great feature is that if I see a student making a conceptual error, I can write a comment, and my comment can be pulled up by other graders when they see the same mistake on the same paper. And this is a good way to get uniform grading across different graders. Okay. So here's an example of a play, pause it, quiz. So on the right, you see that my end of summary lecture, and then on the left is a question, and all they have to do is select the correct answer or select an answer, and they're done. Okay. So this is the way that this is a view in Gradescope. So on the left is the blank page that a student would then, in each box, fill out. And on the right is, if it's correct, I just hit the correct. And if it's wrong, I deduct a point. So just to show you what it looks like. So here's an actual student paper. And you can see that we've deducted all 14 points. And there's a comment, because the student made a conceptual error. So I will stop here before turning it over to my colleague.
Okay.
Any questions? Maybe we'll have questions at the end. Okay.
There you go. Just get Erica like that, and I'll get your PowerPoint up.
I'll run it from here.
Oh, okay.
Can you guys hear me okay? Very good. There we go. Thanks. My name is Erica Carlson. I'm also a professor in the Department of Physics and Astronomy, and I have been teaching the class that's right after Andy. So Andy gets those engineering students in their first semester for mechanics, and then I get them in their second semester for electricity and magnetism. And I'll tell you about some of our use of technology in the classroom, and it's not specific to me. There's many people in our department who use various technologies. Okay, so some of the technologies that we use include BoilerCast. Anybody here use BoilerCast? I love this. I actually, I'm a technophile. You should know that about me. If you see the crazy Segway lady around campus, it's me. I do commute to campus by robot because robots are cool. And we're on an engineering campus, and we should enjoy these wonderful things engineers make. So in fact, eons ago, I had the first college science course to be podcast in iTunes, back when iTunes U was going. And I was doing it all on my own at the time. A student simply asked, I love the interactions with students, right? A student asked, may I record your lectures? And I said, Well, that's a good idea. Yes, you may if you give me the file afterward and I can make it available to everyone. And so that's how we started the podcasting experiment. And so at first I was doing it all on my own, and it was kind of a painful process. But now, very quickly after that, Purdue started automating it so that I can go online, request it, and I don't have to do a thing. They record the audio, they record what goes up on the screen, and students can access it afterwards. And students like having that available, right? I always make sure I'm in a Boiler-enabled classroom and make sure I click yes on that, because students tell me that they enjoy being able to catch up if they miss a class, being able to review if something went too quickly. And I have even had students tell me, I thought that part of lecture was so cool, I just had to show it to my roommate. You're like, yes, that's exactly what we want, because physics is cool. We use online homework, we use online quizzes, we use iClickers, the little feedback devices where we can take immediate data on student answers. I have used wikis in the past. We use course management systems, email lists, demonstrations, the list goes on. We have a YouTube channel from Electricity and Magnetism now that has more subscribers than students were enrolled. So we use a variety. I'm always willing to try a new technology if I think it will help my students. So here's my philosophy of technology in general in trying to help people learn. Good technology should add value, and it should be easy to use. It should be simple. And bad technology is not simple to use, and it distracts my students from the learning. And so I don't want that. I don't want technology at the expense of learning. And in fact, bad technology I have experienced can make my students angry. If it just doesn't work and it's too frustrating, they get frustrated with the entire course, and that reflects negatively on their experience in the classroom. Let me first tell you a little bit about how I use iClickers in Physics 272, which is our large lecture electricity and magnetism course. In the semesters that I have taught it, we have had about 500 students. We break them up into 2 lectures, 250 students in one lecture, 250 students in the other. And then, of course, we divide and conquer in other components of the course. We have labs that are much smaller meetings, and we have recitations that are much smaller meetings, and we have a help center that's staffed throughout business hours and even into the evening where students can get individual help. There's lots of ways that we break it down and give students the opportunity to interact with multiple instructors. And I even tell them we have an army of teaching assistants. Shop around when you go to the help center. If you don't interact well with one person in the help center, there are a lot of people there. Maybe you'll find that another TA is better at answering your questions. And so, don't be afraid to ask multiple instructors for help. As far as iClickers go, these are things that students love them or hate them. So on the teaching evaluations that I get back, I get a lot of comments on the iClicker use. Most of them are very positive. There's always the negative comments so that you know it was real data. So here's an example of a negative comment. I would remove the iClicker questions. Some students learn best by reading the book. That's fair. If you don't learn well by coming to lecture, I don't want to force people to come to lecture. In fact, I always set a little bit of point value for iClickers so that students feel that they do get some immediate reward for having played along and done the system, but I always set the point value so low that students can get an A+ without getting any of them. That's just part of my own teaching philosophy that I totally agree with this student. If you learn better from the book than you do from me, I don't want to waste your time. And so I'm not into using iClickers to require student attendance. I don't think that's the right thing for adults at the college level. Here are some examples of good feedback. I like that she's more interested in the reasoning behind the answer. Multiple positive comments. And in fact, sometimes people will say, oh, I like the way you use them better than this other class that used iClickers. So rather than try to describe to you the method, I'm going to put you through an iClicker, okay? So I know you don't have an iClicker in hand. We're just going to fake it. So here's an example. This is an actual iClicker question that I give when I'm actually teaching the mechanics class, okay? So how many senses do you have? But here's how I like to run it, all right? So first, I want you to pretend you have an iClicker, okay? And first, I want you to answer this question silently on your own. I'm going to give you 30 seconds to answer the question. How many senses do you have? Do me a favor and pretend you have an iClicker, and I want you to commit. It's important that you know what you would choose on your own. So I'll give you 30 seconds on your own, silently, commit to a question and just write it down. No one else has to see it. Do you need more time? You're okay? All right, this is a little bit simpler question than a lot of the ones we give in class. With actual iClickers, I get immediate feedback, and I can tell what percentage of students have replied. And so I can hold off on the next phase until I'm sure the right number of students has made a commitment, okay? And I can see who's choosing, I can see how many people, what percentage are choosing which answer. Now at this point, I'd like you to talk to each other, okay? So I'd like you to take 30 seconds and convince your neighbor that your answer is right. And if you're not close enough to a neighbor, move and find one. All right, I hear the discussion's kind of dying down, so before they ramp back up into other topics, which does happen in a classroom, let me pull it back together and let's discuss a little bit. So before I grade this, I'm not going to grade you guys today, but before I grade these, we go through a long process, and so the students know they should be putting in answers, and they're welcome to change their answer, and they get plenty of warning before I cut things off and actually grade the question. So at this point, I'd like to get some of the answers that you're coming up with, but I'm much more interested, actually, not in exactly which answer you chose, but why you chose the answer. I want to draw out the lines of reasoning. So would anybody like to give us a line of reasoning that came up in your discussion? Oh, fantastic. We don't have this in a classroom. People just have to yell. Thank you. It's excellent having you here.
So our table looked at the question again, how many senses do you have? And depending on the person who's answering the question, they could have multiple answers in this question. So then we got down to, we really hope no one at our table sees dead people.
Thanks. Other comments or lines of reasoning?
So I can tell you, I picked D, and I talked to people at our table, because if you think of the basic five, we always go past that, like your sense of proprioception, your body in space, and you sure mentioned temperature. So we were at 7, and we couldn't go past 7 because we also don't see dead people. So anybody else?
So proprioception, as I understand it, is even if I close my eyes, I have a sense that my hand's here and my hand's here. Is that what you're referring to as proprioception?
Yeah, your sense of your body in space.
Yeah.
Who else?
Who's got another line of reasoning you want to tell us about? Oh, Chantal.
Ma'am, well, now I just said, well, now I'm really confused. I need it to be. But our line of reasoning was sort of like, well, the textbook, acceptable published answers, or the emerging answers, if you think about it more broadly. So that was the line of reasoning. Are we going textbook or beyond? or something
You
else.
had that dilemma of what am I looking for, right? Isn't that frustrating? Yeah. All right. Okay. All right, and again, I always tell the students I'm much more interested in your line of reasoning at this point in the discussion because when you get to the test, it's just you and the exam in your brain. And your brain will present you with multiple lines of reasoning, and you need to figure out which ones are correct. And there can be multiple, right? There's only one answer in physics. There are many ways to get the wrong answer, but there are usually more than one way to get the right answer. And I like to draw out those multiple lines of reasoning so that students know. I want them to commit so they know what they actually chose and they're not fooling themselves. I want them to discuss and defend their answer. And I want them to hear multiple lines of reasoning. And then we as a class decide, this was a path that looked good, but it went wrong here. Okay, so let's not choose that one. And then here's one of those valid lines of reasoning. So I'm looking for the big picture there. So did anybody come up with a sense that wasn't mentioned yet? Just curious. Okay. Oh, please. What is it? Oh, common sense. I love it. I love it. Okay, common sense. Excellent. I actually love this interaction with students because I learned about proprioception one day in class. I didn't know about it, and the students brought it up, and I said, oh my goodness, you're right. There's another sense I didn't know about. So I bring this up in a mechanics class when we are starting to discuss circular acceleration. Circular acceleration, right, is if you spin around, all right? And how many people have had the experience, like maybe, it's okay if it was recent, but I'm thinking more in your childhood, maybe you did this thing where you spin around on a field of grass until you get dizzy and fall over. Anybody care to admit to that? You don't have to, but I've done it. All right, you actually have a sense organ that does that, and you have circular accelerometers inside your head, and there are 3 little tubes of liquid, one for each rotational axis, and there's a flap that bends when the liquid spins around inside that organ, and that's that sense you have that you're spinning. When you feel like you're spinning, that sense organ. It's called the vestibular system, and it's behind your ear. So it's an actual physical organ that tells you whether or not you are experiencing circular acceleration, which is a great segue into circular acceleration discussions in class. Everybody likes circular acceleration, right? Because it's fun. So you guys came up with more than 7. So if this were our class, I'd have to upgrade, and start moving down the list for more. And I always have some students who tell me they see dead people, and I don't really know how to handle that in a physics classroom, except I do want people to have fun. That is one of my major learning goals, is that people enjoy the learning experience. Let me tell you about an example of technology and how a different type of technology that we employed, and we did some actual education research experiments with them in collaboration with the Center for Instructional Excellence, which was fantastic for me to collaborate with them. There's no way I would attempt something like this on my own without their backing and without their training. I did go through the IMPACT course and benefited tremendously from that, and I had come away from IMPACT with a million ideas. So it was great to have their interaction to hone things down and say, well, what can we test? So we did, in fact, try a randomized controlled trial of 500 students each time, fall 2016, and we repeated the exact same thing in fall 2017. And we actually randomly assigned students into different online homework sections. So one set of students, roughly half, not exactly half, otherwise that's not random, right? So roughly half did online homework business as usual. They didn't have any they were much less in control of how they spent their time. They just needed to get the homework done. The other group, which by the way, as far as the students knew, I labeled them Group 1 and Group A because I didn't want them to think they were ranked in any way. So Group 1, actually it's really Group A. Group A did the online quizzes, and they had access to the entire bank of quizzes until they went to do their quiz. So they knew exactly what questions they might be asked. They were promised they'd get asked a subset of those questions when it came time. My hope in designing this was that the students who did the quizzes, since they had much more control over how they spent their time, they weren't required to do the homeworks, they could make choices about which pieces of the material they studied longer. They had freedom to do that. My hope and prediction was that the quiz section would do better because they had more control over how they were spending their time. It's that self-determination theory. So here's what things looked like and of course, these are my preliminary results from the pieces that I have access to. There's an excellent statistical team that will tell you later all the ins and outs of exactly what's going on and error bars and what's statistically significant. So take this with a grain of salt. This is just me, the not statistician, telling you what's in my grade book. In fall 2016, the business as usual section did a little bit better by 0.7% higher. That's actually a small number, so I don't know without the statistics people checking into that if that was significant. And the analysis is in progress. I have a suspicion, which will be interesting to see how the analysis team, what they get out of it. I strongly suspect, based on my conversations with students, that there's a bimodal distribution in there of how the quiz section responded. Because in asking, so I'm always asking students for feedback about every component of the course. Before class, after class, when I see them in the hallway, at the help center, whatever, I'm always asking them, how's the class going? How's the class going? And so the students who had these quiz sections loved it or hated it. And there were some of them who did what I envisioned. They practiced with the test bank until they felt confident, and then they took the quiz. There were some students who did not practice and just went straight to the quiz with no training, and they hated it. And so I kind of have a suspicion that when the statisticians dig into, say, time on task and student perception surveys, we'll get a little more information on exactly what happened. But suffice it to say that the raw score there looks like the homework section, the business as usual, was actually outperformed. In fall 2017, we got a very surprising result, all right? The homework section scored 4.43% higher than the quiz section. This is in their final course grade. Before I adjusted it, okay? They know if we're running one of these trials, I promised them at the end of the semester, here's how I help them get on board. I say, this will not hurt your grade. You might end up having a boost to your grade at the end to make sure that everybody's average was the same. So I tell them the worst that can happen is you might get a higher grade than you earned. So that helps get students on board. So the homework section scored 4.43% higher than the quiz section in their final course grade, which means, of course, I took the other section and raised them to match before releasing grades out into the wild. But that's different, right? So what happened in this? Here's what happened. It's an example of technology being distracting in that semester. Something, as was discussed by previous presenters, sometimes things don't go as planned. And so some things happened that semester that were not as planned. And actually, our technology broke and failed miserably for one section. And it was actually the quiz section who had tremendous problems. So the unfortunate thing was that at the end of the day, what had happened was that the company that we were using sold that section of students incorrect codes. And so I had 250 students who, we had to go through a long discovery process of what is going on. So this is some of my summary of what happened on what date and what students are reporting to me and what we're doing about it and what's happening, and I'm kind of trying to log how many people are getting these problems and whatnot. And at some point, about 2 or 3 weeks in, we realized it's only the one section that's having all the problems. So that section, the technology just failed them miserably, which I think is probably the biggest, given that that's the only difference between the 2 years. I think that's the biggest difference that is responsible for that big change. We had a technology fail. The company did not perform as they should have, and we had poor customer service from them that semester, unfortunately. So back to the philosophy of technology then. I'm going to update it. Good technology also works. So we're always keeping this in mind when evaluating the technology that we're using. Suffice it to say, I'm not going to use that company again. Good technology works and has sufficient tech support. When you have hundreds of students, that's absolutely essential, right? You can't have hundreds of students coming to you for tech support. It's got to be seamless. And bad technology we've seen actually negatively impact learning. So I'll wrap it up with that, and both Andy and I can take questions. Jenny, how long do we take questions?
about 10 minutes or so, and we're going to ask Andy to come up. And while Andy comes up and Erica and Andy share the clip-on mic, I wanted to share with you, because I'm part of the team that's working on the data from Erica's class. Not only is there that shift in grades, there's a really big, significant shift in the students' perception of the learning climate. Students in the quiz section in fall of 2016 loved it. They really perceived an autonomy supportive environment in that classroom with all those quiz questions to look at. And in fall 2017, as you might predict, their perception of the learning climate precipitously dropped off. And so we're investigating all of these results together, but it was really shocking. All right, yes, questions. I saw a hand in the back, the guy in the green shirt there first. Thank you, Nastasha.
Thank you. This is hello? Okay. I'm not right? Okay.
We can hear you.
Good. This is really for Dr. Carlson. I wanted to, the clicker example was really interesting and enjoyable. How do you finish it? What's the ultimate grade?
Oh, yeah, that's an excellent point. So I didn't finish it for you, did I? So after the class discussion, typically it's a physics question that has one right answer. And so we get there, and I circle the right answer, and I say, I am going to close the clicker question in 3, 2, 1. So they see that after. Everybody has the opportunity to get the right answer before I actually grade it. But just so you know, it's real data, real students. Not everybody picks the right answer. I don't know why.
I guess maybe one question for each. So first, we ran into this thing where you give people options and then none of them are correct. And so how do you deal with the committing thing versus the cognitive dissonance that if I don't believe I'm committing to a correct answer, right? I mean, because like we talked about.
Are you asking me about the clicker question?
Yeah. So this one in particular. So if there's like 12 senses or something, right?
Oh,
then,
sure.
Right,
No,
then,
this is great. I mean, with real interactions with real students, I never know what's going to happen, and I do learn from my students. And so there are clicker questions that come up, even after it's been run through 2 or 3 years of students. I'll have some year of students break it, and they'll point out something that tells me that either there's 2 correct answers or the question was invalid for whatever reason. And so at that point, I just declare, great discussion. I'm going to give any answer you put down correct. And then I just change how I grade it later.
And then maybe one for Andy. So for the bite-sized videos, do those tend to be sort of talking head videos or like animations, or how do you sort of structure those kinds of activities?
So each video begins with a headshot of me, just so they know there's a human behind the scene, and then it goes to essentially a computer screen. And yeah, there are some animations, but it's mostly talking and leading people through through the slides. I mean, it's an open question to me whether those slides are helping students learn. And so what as Erica said, a student made a request one day to put the full slides, just the PowerPoints without the video, in Blackboard. And so I've done that. And I tell students, look, what the format of this class may not be for everybody. And I allow students to transfer out into the traditional format or transfer in, and some of that takes place every semester. Some students will go through the videos religiously, others may just look at the slides because, there are different learning styles.
Yeah, just a follow-up. Is that working? Follow-up on that, Andy, regarding the video. You are embedding some questions also using play post. And did you evaluate that and how effective that is in encouraging students actually to, yeah?
Good question. Actually, this is, I've not had the opportunity to do that yet. I mean, one of the ongoing projects of mine is to evaluate what I'm doing effectively or less effectively, and also to compare my students' performance to the performance in the regular class, where we have common exams. And that's actually a tricky exercise because there's some self-selection going on, and so as the previous speakers indicated, there are always confounding factors that you have to account for. And I can honestly say that I have done no harm. Have I done great good? Honestly, I can't say I've done great good, but at least I haven't done any harm yet. And I can tell you also, informal feedback, it works very well for some students. The flipped classroom. I won't claim that it works for everybody.
And just a follow-up to Erica, if you don't mind, regarding the iClickers. I understand that if the iClickers are used in multiple courses, the student will, because the student have to pay for them, they will be encouraged to use them. So if it is one class, did you try to use Echo 360 and adapt it as a clicker rather than buying a clicker?
I've only used the iClickers. I haven't tried the other systems. Go ahead.
And I gave up on, and I don't use iClickers. So I saved my students a little money in that sense. And I tell them that. Yeah.
I have a question about team building and how it's incorporated. I know that 172, all of them, but is team building better used because of the impact class?
I'm not sure I quite understand.
Okay, so team building is one of the requirements of the College of Science that is accomplished by the class of 172, either in the regular mode or in the impact mode.
Right.
Has it been easier to implement team building successfully, or is there more team building? I don't know if you can say
Interesting question. So in the regular class, in the regular format, students work in teams once a week on the recitation problem and in lab. And in my class, there's a lot more opportunity to work as a team. And so I haven't done a formal assessment, but I can see that most of the tables work very well together. There's a lot of discussion, mostly on physics, not entirely on physics. But over the course of a semester, these people see a lot of each other and a lot of me and my teaching assistants. And so we get a pretty good sense of, what groups are functioning well and which ones are not. And essentially, they all seem to function pretty highly. But that's just, my impression.
Has this continued for 2008, fall of 18? Your study was fall 16, fall 17. Has your study continued, Erica?
Sure.
I'm not sure who collected the data.
Okay, so we're doing two separate experiments. So the one that I was running in Physics 272 is not going on anymore. Yeah.
I can add to that question slightly. Our study for STEAM, our data collection finished in fall of 2018, and Erica, and this is something that I'm sure our other grant recipients can also talk about. People move around a lot, and so for the last semester of our data collection, we actually collected some motivation measures and the BEMA, which is the Brief Electricity and Magnetism Test.
Brief electricity and magnetism assessment.
Yes,
well done.
I did pretty well, thank you. Not a physicist. So anyway, we collected that same data that Erica was collecting for our study with a different instructor. We haven't had it, we just finished getting that data, so we haven't had a chance to analyze it, but we have an interesting pattern. We have 3 semesters of Erica, 2 where she was running her intervention, and then we also have the motivation and grade and BEMA data for another instructor. So that was how that stacked up like that. So, well, I want to thank Andy and Erica for taking time out of their day to join us here.